Hello students, welcome you to this session. We are studying inverse, right? How to find inverse of a matrix I taught in my previous video. So few more sums we are going to continue and some of the application of inverse, okay, that I'm going to teach today. So the formula for A inverse, hope you remember, what's the formula for A inverse? 1 by determinant A into adjoint A. Then inverse exists only for non-singular matrix. Determinant A not equal to 0. Of course, it must be a square matrix. Okay. Now let us continue the next sum. Sum number 8 you take. Show that the matrices are inverses of each other. Two matrices given in 10th standard already you studied, right? But there we don't know how to find inverse, but we prove two matrices are inverses to each other. So what we have to do, you find A into B and B into A also. In both the cases you get I. Then you can say A and B are inverses to each other. Some fractions given, but happy news, in all the denominators are what? Same. So you can take it out. In a matrix, if something is common for all the elements, then only you can take it out. In determinant not like that, right? Even in one row something common you can take it out. But in matrix, if something is common, 1 by 5 is common in all the elements, you can take it out and you can do that calculation easily. Okay, so now let us find AB first. So A is 2, 2, 1, 1, 3, 1, 1, 2, 2. Into B. In B, I'm taking 1 by 5 outside. So what do you get then? 4 minus 2 minus 1 minus 1, 3 minus 1. But then again minus 1 minus 2, 4. So this is A into B. So that 1 by 5 we write as it is. 1 by 5 into, you have to multiply row by column, right? But already I said what answer you are supposed to get, right? You have to get what? I. You have to get I. I means it is what? 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the answer you are supposed to get. Then definitely you would have got 1 by 5 into 5, 0, 0, 0, 5, 0, 0, 0, 5. Some hints for you. But without multiplication, don't do that. Okay, so you have to do that, but you have the idea. You must have an idea what answer you are supposed to get. You know that, right? So now row by column you check. 2 into 4, 8. 2 into minus 1, minus 2. 1 into minus 1, minus 1. Now we can check it, right? Yes, it is 5 only. First row, second column. 2 into minus 2, minus 4. 2 into 3, 6. Plus 1 into minus 2, minus 2. If you simplify, minus 6 plus 6, so it is what? 0. First row, third column, 2 into minus 1, minus 2. 2 into minus 1, again minus 2. So 1 into 4, it is 4, right? So you will get 0. Like that, you can simplify, right? Second row, first column, 1 into 4, 4. 3 into minus 1, minus 3. 1 into minus 1, minus 1. So that is 0. Second row, second column, 1 into minus 2, minus 2. 3 into 3, 9. 1 into minus 2, it is what? Minus 2. See, 9 and minus 4, you will get what? 5. Like that, I'm sure you can complete the remaining, right? And check whether you are getting this value and you are getting I. Okay, so AB is equal to I. You find B into A also. You change the order, that's all. See that you are getting I there also. So you know how to multiply. Once AB, you are getting AB equal to BA equal to I, you can say A and B are inverses to each other. Okay, so hope you understood that. Now let's go for the next question. Another simple question, just I'm going to tell you the method only. So A and B are two matrices. Verify that AB inverse equal to, already we studied the rule, right? AB inverse equal to B inverse into A inverse. So how can you find AB inverse? First you find AB. A is 3, 7, 2, 5 into B is 6, 8, 7, 9. First row, first column, 3 into 6, 18 plus 7, 7s are 49. First row, second column, 24, 63. Second row, first column, 12 plus 35. Then second row, second column, 2 into 8, 16 plus 9 5s are 45. So you can add, simplify this. So when you simplify, you are getting what? 67, 87, right? Then 47, then 61. So this is AB. So we want AB inverse. So you need determinant value and adjoint value, right? So you find determinant of AB 67, 87, 47, 61. The great advantage for business math students is you are allowed to use calculator, okay? Ordinary calculator, not scientific calculator. So calculation, there is no problem for you, right? But practice with the same calculator what we are going to use for the annual examination, okay? So now you don't use some mobile calculator and all, right? So what you want to do for the annual examination, practice now itself. So that time there won't be any problem, so familiar one, right? So 67 into 61, right? Now I'm giving the value 4087. 4087 minus 4089 you will get, okay? So you are getting minus 2, which is not equal to 0, right? Now adjoint AB. Adjoint AB. So it is a 2 by 2. So easily you can do principal diagonal. So this is AB, no? Principal diagonal interchange 67, 61. You write 61, 67. Other two elements change the sign. 87 you write minus 87. 47 you write minus 47. So now AB inverse, right? You can write AB inverse is equal to 1 by determinant AB into adjoint AB. Instead of A, we have AB, that's all. A inverse, you know, A inverse is 1 by determinant A into adjoint A. Instead of A, what do you have here? AB. Okay, so just to substitute 1 by determinant AB is minus 2. I'm writing minus here and 2 here, okay, minus 2. Adjoint AB is 61, minus 87, minus 47, 67. If every element is divisible by 2, you divide it. Otherwise, minus 61 by 2, minus 47 by 2. Anyhow, you cannot simplify, so better you can leave like this. So this is equation number 1. This is the answer for LHS. Same way, you have to find what? RHS. So first, you have to find what? B inverse. What's the formula for B inverse? 1 by determinant B into adjoint B. So adjoint B, since it's a 2 by 2, you can do directly. Determinant B, find out. Sometimes determinant value may be 1. So, but still you have to find, substitute, then 1 by 1, it is 1, you write like that, okay? So here, sometimes the students make mistakes. So they think every time it is 1, so they take only adjoint. No, 1 by determinant value. Sometimes it is 1, but still you do that one, okay? B inverse you find out, then you find A inverse also, 1 by determinant A into adjoint A. Hope you are familiar with that one. Then you multiply these two answers. So B inverse into A inverse. The order is important, and when you simplify, you will get exactly the same answer. 1 by 2 into the same answer. And take it as 2. Then finally you say from, conclusion important, from 1 and 2, what can you say? AB inverse is equal to, AB inverse is equal to B inverse into A inverse. I'll explain all the questions, but I won't do all the questions because I don't want to waste time. You know that, but you have to practice it, okay? So now let's go for the 10th question. Find lambda. Find lambda if this matrix has no inverse. This matrix has no inverse. When we say the matrix has no inverse, if it is singular, right? So matrix inverse exists when the matrix is non-singular. So inverse exists when determinant A is not equal to 0. Here they said there is no inverse. No inverse means inverse does not exist. So determinant A equal to 0. So we take this as A. Let A equal to the matrix 1, 1, 3, 2 lambda 4, 9, 7, 11. Now you can say since A has no inverse, since A have no inverse, what can you say? Determinant A is equal to 0. Okay. So if you want, you can say A is singular. Singular means determinant A is equal to 0. Determinant A converted as a determinant 1, 1, 3. 2 lambda 4. 9, 7, 11 equal to 0. You know how to expand and find lambda. Anyhow, I'll help you this sum fully. So 1 into, leave the first row, leave that row, that column. Lambda into 11. 11 lambda minus 7 fours are 28. Take the second number, minus 1 into. Leave that particular row and column, 2 into 11. 22 minus 9 fours are 36. Plus 3 into, leave that row and column, 2 sevens are 14, minus 9 lambda equal to 0, right? Now we simplify this. So 1 into, so no change, 11 lambda minus 1 into 28, 28. Then here you will get minus 14, outside a minus, so minus 1 into minus 14 is plus 14, right? Plus 42. 3 into 14 minus 9 sevens are 27 lambda equal to 0. Simplify the lambdas, minus 27 lambda plus 11 lambda minus 16 lambda, 42, 14, 56 minus 28, it is plus 28 equal to 0. So minus 16 lambda, you take it here, so it becomes plus, right? 16 lambda equal to 28, or lambda is equal to 28 by 16. So lambda equal to, you cancel by 4 table, you will get 7 by 4. So this is when there is no inverse. But when you go for the examination, sometimes the word no, it may not be there. If it is not there, it has inverse. It has inverse means determinant A not equal to 0. So instead of you put determinant A equals 0, you write not equal to 0. Every step you put not equal to 0, then finally you will get lambda not equal to 7 by 4. So read the question very carefully. Now let's go for the next question. XY two matrices given. Find P and Q if Y equal to X inverse. If Y equal to X inverse. Try to recall the concepts what we studied in the previous class. So A equal to B inverse, or B inverse equal to A. That is, A and B are inverses to each other. What is the condition? What do you have to prove? AB equal to I, right? AB equal to BA equal to I. Then you say A equal to B inverse and B equal to A inverse. So that's the easiest way. Otherwise, you have to find X inverse. X inverse is 3 by 3. It will take a lot of time, right? So easy method, you can do that. Listen, what is given? Since Y equal to X inverse, you can say XY equal to YX equal to I. That's all. You take any one part. I'm taking XY equal to I. Substitute. What is X here? 8 minus 1 minus 3 minus 5 1 2 10 minus 1 minus 4. This is X into Y. What is Y? 2 1 minus 1 0 2 1 5 PQ equal to I. What is I? 1 0 0 0 1 0 0 0 1. All of you know how to do matrix multiplication, right? So, but I am going to teach in a very simple way. But for the examination, if you want, you write fully. What they asked to find? It is to find P and Q, that's all. The concept, you know what you'd use? XY equal to I, that's all, right? XY equal to I, that only we are using here. XY equal to I. I want P, right? P is here only, no? So the two matrices are equal means the corresponding elements are equal. So I am going to multiply first row into first column is, you will get the first number, right? First row into second column, you will get what? 0. That is A13 in the answer, sorry, A12. A12 is equal to 0. That when you get first row into second column. So I'm going to take only that. First row into second column. 8 into 1, 8. Minus 1 into 2, it is minus 2. Minus 3 into P, minus 3P equal to 0. From here you will get it, right? 8 minus 2 is what? 6 equal to 3P, or P equal to 6 by 3, right? So P equal to 2. So P value got it. Now to find Q, see Q is here, right? So what I'm going to do, first row, third column I'm going to take. First row, third column, you will get this number. So A13, right? A13 is equal to, that also 0 here. A13, how you are getting? First row, third column. So 8 into minus 1, minus 8. Minus 1 into 1, minus 1. Minus 3 into Q, minus 3Q equal to 0. So minus 9. Minus 3Q, take that side, plus 3Q. So Q equal to minus 9 by 3. So Q equal to minus 3. So your answer is, they asked to find P and Q, that's all. So P value 2 and Q value minus 3. So if you are very particular, you multiply everything, you will get all the 9 elements, okay? Try to simplify, then equate the corresponding elements, you are going to get the same answer. You can save time here, okay? So that's all. So P value 2 and Q value minus 3. So that's all this exercise. So next we are going to see one of the very important thing, how to find solution of a system of linear equations. The lower classes you study, right? If they give two equations in x and y. In the lower class you study even graphical method, right? You draw the graph of two lines, they meet at some point, that is the solution. Then in 10th standard you study some methods, right? In 9th standard I think you would have studied some substitution method. Then you studied elimination method, method of cross multiplication, everything you studied in the lower classes in algebra. If equations are given, two equations or even three equations, how to solve. But now we are going to study how to solve the system of equation using matrix method. So matrix inversion method. Okay, so that's what I'm going to teach now. Listen carefully. Solution of a system of linear equations using matrix inversion method. So listen the theory part, then the sums are very easy only. But of course, matrix inversion method means you must find the inverse, right? So all the cofactor, everything, it is there only. Just again a revision only. One or two extra steps, that's all. So suppose they are giving two equations, say a1x plus b1y equal to c1, a2x plus b2y equal to c2. Okay, so two equations are given in two equations. So if there are three unknowns, they give three equations, right? So here the unknowns are what? X and y. So you have to find x and y. So first, this is the order you have to arrange. X, y, constant to the right side. Suppose z is also there. X, y, z, take the constant to the right side and take the whole system as ax equal to b. You can write it as a matrix equation. Ax equal to b. Ax equal to b, all these matrices. So A means the coefficients alone you take. XY coefficients, what are they? A1, B1, second row A2, B2. If any term is missing, you write 0. If negative is there, you write minus also. This is A. X means unknowns. Here the unknowns are X and Y. Write them as a column matrix, okay? X, Y. If there are three unknowns, you write x, y, z. If the unknowns are a, b, c, you write a, b, c. Okay. Equal to b means the right side value, c1, c2. Hope you understood. A system of equation given, convert it as a matrix equation, ax equal to b. But before that, the system should be in the order x, y, z constant to the right side. Here there is no z, so x, y take constant to the right side. Then ax equal to b. All the three are matrices. A is the coefficients. X is the unknowns, write it as a column matrix, and B is the right side values, the constants. Okay, so Ax equal to B. From here we want to find X, right? I'll give you the formula, but I'll give you the proof also how we are getting. Okay, so from here you can find X. X is equal to, in algebra we write B by X, right? So here you cannot write like that. X is equal to, you cannot divide two matrices, right? Two matrices you can multiply. Have you ever seen this matrix by this matrix? No, right? So X is equal to A inverse into B. X is equal to A inverse into B. This is the only one line you have to study for the next one exercise. X is equal to A inverse into B. Now I will tell you how to find this, how we are getting this one from Ax equal to B. Please listen. Ax equal to B. How to find A? If you want to get that, how to find X. To find X, we don't want that A there, right? So A must get cancelled. So you multiply by A inverse. So where you multiply in the front, so we call it as pre-multiply. pre-multiply by A inverse on both sides. So both the sides you pre-multiply by A inverse. So what do you get here? Listen, we have AX equal to B, right? Pre-multiply by A inverse. So that means in the front you multiply by what? A inverse. Now you group first and second A inverse into A into X equal to A inverse into B. What is A inverse into A? A matrix multiplied by the inverse, you will get what? I. I into X equal to A inverse into B. I is like 1, right? I into X is X. So X equal to A inverse into B. You cannot change the order. You can't write it as B into A inverse. Matrix multiplication is not commutative. Okay. So that is how we are getting X equal to A inverse into B. Hope you understood. Shall we go for the sums? That's all the theory part for this exercise. Okay. Listen. This is 1.3. After this, just one exercise. First chapter will be over, right? So solve by matrix inversion method. Listen. So here there are two variables. What are the two variables? X and Y. So arrange in order. So first one we write 2x plus 3y. Take that minus 5 to the right side plus 5. Equation number 1. Second one is x minus 2y equal to minus 1. So now it is in the correct order, right? So take this as ax equal to b. Ax equal to b. What we did for the theory part, same thing you do here. Coefficients you write 2, 3. Second one, 1 minus 2, right? 1 minus 2. Here the unknowns, x, y as column matrix. In the right side you write the constants, right side values, 5 minus 1. So this is ax equal to b. All capital letter because every letter represents a matrix, okay? So, and immediately write the formula, x is equal to A inverse into B. Okay, x is equal to A inverse into B. B, you know, what is B? That 5 minus 1, right? So we want A inverse. We want A inverse. So we find A inverse. To find A inverse, you start with A. What is A here? 2, 3, 1 minus 2. Since it is a 2 by 2, I am going to teach fully. Okay. 3 by 3 means I leave it to you because you can do that. So it will take a lot of time. So A equal to 2, 3, 1 minus 2. To find A inverse, what do you need? Determinant A and adjoint A. So find determinant A, write it as a determinant 2, 3, 1 minus 2. You multiply minus 4 minus 3. So it is minus 7 which is not equal to 0. Then adjoint A, you write principal diagonal interchange. The 2 minus 2 you interchange. So you will get minus 2, 2. Other two elements you change the sign. So 3 become minus 3 and 1 become minus 1. So this is adjoint A. We want A inverse. A inverse is 1 by determinant A into adjoint A. So 1 by determinant A is minus 7. Adjoint A is minus 2, minus 3, minus 1, 2. So just to leave it, later we see. No, don't divide by minus 7 now. So this is A inverse. Now just to substitute in the first equation, you will get what? X is equal to A inverse into B. X is equal to A inverse into B. That's the first equation. X means unknowns. X, Y. Hope you remember. X, this is our X, right? So X is equal to XY equal to A inverse, we got it. B is what? 5 minus 1. B is 5 minus 1. That is B. A inverse is 1 by minus 7 into, so you got it here, right? Minus 2, minus 3, minus 1, 2. So 1 by minus 7 into. Now matrix multiplication, first row, first column. First row, first column, minus 2 into 5. What you are getting? Minus 10, minus 3 into minus 1 is what? Plus 3. First row, first column. First row, second column is not there. Now we come down. Second row, first column. Minus 1 into 5. Minus 5. 2 into minus 1 is minus 2. So you are getting, that is 1 by minus 7 into minus 10 plus 3. Minus 7. And here also minus 7, right? So now you divide by what? Minus 7. Every term you divide by minus 7. So minus 7 by minus 7 is 1. Minus 7, that also 1. And left side is what? XY. The two matrices are equal. Don't stop here. Some students, they do everything, but they won't write the last step. Don't stop here. So question is solved. That means you have to find X and Y, right? So you say solution X equal to 1, 1 and Y equal to 1. Corresponding elements are equal. X equal to 1, Y equal to, if you want you can verify. You put X equal to 1 and Y equal to 1 and check it. X is 1, so 1 minus 2 into 1 plus 1. Is it 0? Yes. Here you put X equal to 1, Y equal to 1, 2 into 1, 2 plus 3 minus 5 equal to 0. Just you can verify that. So that's for 2 by 2. If it is 3 by 3, same method, but takes time, right? That will be a 5-mark question. In 2 by 2, suppose only 2 variables, they can ask us a 3-mark question. Now look, anyhow, we'll try one question, but I'll write few things, I'll give the answer, okay? So you can save time. Solve by matrix inversion method. So 3 equations, rewrite them, 3x minus y plus 2z equal to 13. This is the correct order. Sometimes even y and z, they would interchange. So read the question very carefully, okay? So don't simply take the coefficients alone. So you write one time. See the question paper, you write in the answer sheet the equation, so you won't make any mistake, right? So do it very carefully. 2x plus y minus z equal to 3, x plus 3y minus 5z equal to minus 8. So 3 equations, everything given in correct order, right? So practice more questions. In the book they give a lot of questions, the example sums, or you take any 3 equation from your 10th standard book, you solve it, check whether you are getting the answer, okay? So you need a lot of practice here. But use only matrix inversion method. Don't use your 10th standard method and all here, right? Okay, so it is the correct order. So you write the whole system as AX equal to B. And what is A here? A is the coefficients, right? 3 minus 1, 2, 2, 1 minus 1, 1, 3 minus 5. This is A. X is the unknowns. What are the unknowns here? X, Y, Z. B is the right side value. What are the right side value here? 13, 3 minus 8, right? So we want to find X. You write the formula. What is X? X is equal to A inverse into B. That's all. X means this X, Y, Z. B you know. So only thing you need what? A inverse. So you know right from the first day we are studying that only, right? So we want A inverse first. So you need determinant A. So here I'll give the value. You know how to do that. That part I want you to finish it, okay? Don't simply write the answers. So determinant A, you expand and see, you have to get minus 5, which is not equal to 0. Then you find all the cofactors, form a cofactor matrix, right? Form a cofactor matrix. Then you take the transpose of that, you will get adjoint A. Lot of steps in between, right? So I'm giving the value directly, adjoint A. It is a matrix, so you must know when to use matrix symbol, when to use determinant symbol. When you find determinant A, determinant symbol. All other cases we are going to write only matrix symbol, right? So adjoint A, you will be getting plus 1, minus 1, 9 minus 17, 7, 5 minus 10, 5. So this is adjoint A. How to find adjoint A? That itself a 5-mark question. Okay, so finding all the cofactors and all. Those who have doubt, watch our previous videos that we explained clearly. Okay, so this is adjoint A. Now we write A inverse. A inverse is equal to 1 by determinant A into adjoint A. So that is 1 by determinant A is minus 5. 1 by minus 5 into adjoint A. What is that? Minus 2, 1, minus 1, 9, minus 17, 7, 5 minus 10, 5. So this is A inverse. So now you know A inverse, we want to find X, right? So substitute in the first equation, X equal to A inverse into B. X means X, Y, Z. A inverse, you got it now. 1 by minus 5 into minus 2, 1 minus 1, 9 minus 17, 7, 5 minus 10, 5. Into B. B is the right side value. So first is written, right? 13, 3 minus 8. 13, 3 minus 8. Now just one step you have to multiply, right? So 1 by minus 5 into first row, first column, right? First row, first column. You multiply and see minus 2 into 13, minus 26. 1 into 3, it is plus 3. Minus into minus plus 8, right? First row, first column. No, second column is not there. Now we come down. Second row, first column. 9 into 13, 117, minus 17 into 3, minus 51, minus 56. Now come to the third row. 5 into 13, 65, minus 10 into 3, minus 30, minus 40, right? 5 and 8. So that is 1 by minus 5 into. See what you're getting? 8 plus 3, 11. You subtract here, you will get minus 15. Here you are getting 107. If you subtract, you will get 10, right? 117 minus 7, yes. Next you are getting minus 70. Minus 70 plus 65 is minus 5. So everything you can divide it, right? So even there is a small mistake you can find out. So now divide everything by minus 5. So you change the sign because we are multiplied by minus, right? So change the sign and divide by 5. Change the sign, minus become plus. 15 if you divide by 5 you will get 3. Second one, plus 10. Change the sign, you will get minus. Divide by 5, 2. Next one, change the sign, plus. 5 by 5 is 1. So this is the value of x, y, z. Don't stop here. So which implies x equal to 3, y equal to minus 2, z equal to 1. Okay, so, but here the adjoint, that part I left out, determined you have to expand it. And like this, you practice more questions, what is given in your textbook. And then some statements, some application sum. To do the application sum, this is more important, right? One statement is given, just I'll explain to you how to frame the equation. Once I frame the equation, then you have to do that, right? So in the next class, I will take the statement sums. Only thing I'll explain how to get the equations. Then you have to do that. So practice this well. So this is more important. So prepare well. We'll continue in the next class.